So now we're going to keep adding to what we've done. So we just did the Pythagorean theorem. We've done something similar to this lesson, at least the first part, and that's the multiplying part. When we get to the division part, that's going to be unique, so we're going to have to be careful there. All right, so 11.7 is multiplying, dividing radical expressions. Binomials, look, we already know what to do. We know to distribute. We know to distribute. Now, what still gets some of you with radicals? Some of you still don't always look to simplify your radicals. Now, look, honestly, there is nothing I could teach you. Listen now, look at me. There is nothing I can teach you to be looking to simplify. I've told you, and I've told you, you've got to always look to simplify. That's all I can do. Most of you, almost all of you, know how to simplify. But you don't always look to simplify. That's your brain. You have to get a point where you say to yourself, I have to always look to simplify. I don't know if you got to put it on a 3x5 card and memorize. I don't know what you got to do, but there's nothing to teach. It's, okay, I always have to look to simplify. So be careful. So again, you see off to the right, look to SBUM, look to simplify before you multiply because we're multiplying. Does everything simplify? No. And that's why students sometimes don't look to simplify. It was the same thing in factoring. Are there always common factors that you factor out first? No, but you always have to look to simplify. By the way, look at the back page of your test. How many of you already have forgotten to factor out common factors first? And here's the weirdest thing in the world. Look on the front of your test and look at the short answer question. And see if you put in the short answer blank, factor out common factors first, and yet you didn't do it when you got to the factoring. Well, that's a disconnect. How could you fill in the short answer blank that says factor out common factors first, and then you get to the factoring and you don't factor out common factors first? Again, that's your first thought. That's on you. I've taught it to you. That's on you. You have to remember that. You don't remember it, I can't help you. You have to remember it. Remembering it, you got to build your brain paths. How do you do that? You got to keep reviewing. If you're not going to get there. All right, so here, be careful. You have to always be looking to simplify when we're multiplying. Do you always have simplification going on? No, but you're always looking. So when I do this first distribution, right, I'm looking. What kind of root am I doing? Square root. So how many of the same factor do I need to be able to take a square root? 2. So that's what I'm thinking when I do it. So I look at it. I got 1, 2, and 1, 3. Is that going to be 2 of anything? No. So I can say right off the bat, square root of 6. But I'm thinking, I'm looking. So that's the first distribution. When I distribute the square root of 2 to the back. All right. So what can get you here? Well, the left is a square root of 2. The right is just a number of 4. So what do you get when you multiply a square root of 2 times a 4? You get a 4 times the square root of 2. Do we need that plus sign? Yeah, you need the plus sign, right, to keep everything in its place. So that's a 4 times square root of 2. Next, we're distributing the negative square root of 5, right? And again, when I'm looking at a square root of 5 times a square root of 3, I'm thinking I got 1, 5, and 1, 3. There's no simplifying. So I'm going to write negative the square root of 15. And then finally, the last distribution. And by the way, it was a shame on the test. Numbers of you missed on the back page the problem where you were multiplying a negative times a negative and you kept it negative. Man, stuff like that will just kill you. Negative times it. So again, be careful. This is a negative square root of 5 times a positive 4 for a negative 4 times the square root of 5. I'm going to look when I'm done to see if perchance there are any like radicals that I can add. Just like you would like terms whenever you multiply any binomials. And there are none, but I looked. I did think it through. I looked. So that's the answer on that one. Nothing more to do. It's a pretty simplistic one. Now when we get to the second one, you're already going to have simplifying going on. So now I got a 2 times the square root of 6, right? And now we're going times a 2 times the square root of 14. Is this one going to have some simplifying going on in the radicand? Yeah. So I'll do the 2 times 2 and get 4. And again, you can do this in your head, but I'm just telling you, 90% of you are going to miss the problem doing them all in your head. So I got a 6 and a 14. I'm going to leave them a 6 and a 14. So I know I got to factor in more to get out that common 2 that's there. Now I'm looking in the back. Positive 2 times a positive 5 is a positive 10. And again, with a 6 and a 2, are you going to be able to simplify? Yeah, so I'm going to leave it 6 times 2. Whenever I can simplify, I leave it as just the factors together. All right, let's distribute the back term. Don't forget to distribute your negative. All right, negative 3 times 2 is a negative 6. 7 and 14, am I going to be able to simplify? Yep, so I'm going to leave it a 7 times a 14. And in the back, negative 3 times 5, negative 15. And how are you going to write the last radical? Right? You're going to write square root of 14, right? Because again, you're looking and you got 1, 7 and 1, 2. And that's not going to simplify, right? Now look, let me say this again, and I got to say this more all the time. If you're just copying what I'm doing, and look, I can look out there. I see some of you. This is what I see. I see you straining to look on the board to see what you have to copy. I'm telling you, if you're copying everything I write, you are learning 0. 0. If you're just copying. You have to be thinking about what's being said and thinking about what's on your paper and thinking about what you would do on your paper and therefore then writing what it is. So if you're just copying, you are learning 0. Okay, so now we got to go through and finish off all the simplifying. So go ahead and finish this thing off. Okay, so where do we end up here? On the left, what do we got? 8 times the square root of 3. Oh, square root of 21. See, be careful. Am I frozen? Okay. 8 times the square root of 21, right? You got that 3 there. You got that 7 left. 8 times the square root of 21. Second one, 2 times 10 is 20, positive 20. And the only thing left in that one is the square root of 3. Negative 7 times 6 is a negative 42 times the square root of 2. And then minus 15 times the square root of 14. I better look. Did any of these add? No, but I'm looking. You got a square root of 21, a square root of 3, a square root of 2, and a square root of 14. None of them add, but I am looking. I am looking. Questions on that? So 8 times the square root of 21 plus 20 times the square root of 3 minus 42 times the square root of 2 minus 15 times the square root of 14. That's just simplifying. Okay, look at C. What kind of thing is C? It's a name for C. Ashton, it is a difference of 2 squares. Yes? Right? 2 binomials, exact same front and back, except one is a plus sign in the middle, and the other is a minus in the middle. Okay. There's a shortcut to multiplying these, but if you don't remember, you're just going to multiply them out longhand. So just go ahead and multiply that out, see where you end up. Go ahead and multiply out that difference of 2 squares. Okay, if you're not done yet, just stop and look up here. Just stop and look up here. So a negative, or a square root of 7 times a square root of 7 is a 7. All right. On the back, you get a negative 5 times the square root of 7. When you distribute the positive 5, you get positive 5 times the square root of 7. Those are going to add out. And then, of course, the very back is negative 25. These are gone. What is the answer? Negative 18. Right? How many got that correct? Just the way it turned out. Now, you get all different possibilities, but look, all it is two binomials. We know how to distribute. I hope when you did -5 of them and a +5 of them, you have nothing left. 5 of them, take away 5 of them is nothing. All right, go ahead and try D. Do D. Okay, so let's go back to a moment ago. Let's see, do I still have it? Yes, right here. Right, Alexis asked me about this problem. Right? And I told her, everybody, you looking up here? Because everyone's not looking, you one's messing this up. I told you about how you can apply the exponent rule to those situations, but you could not because this is a binomial, and therefore you had to do that, right? So hopefully you applied that to this problem, right? Most of you did, some of you did not. Now, we just did that 5 minutes ago, 20 minutes ago maybe. So again, you got to be careful. You can't, after we show you something, you got to try to assimilate that and put it into practice. All right, so what happens here then is hopefully you decide that this is square root of 3 minus 2 times the square root of 2 times the square root of 3 minus 2 times the square root of 2. Normally what I would just do is just cross out the exponent and write it one more time to save myself time. Come on, Windows. All right. Square root of 3 times square root of 3, 3. Square root of 3 times -2 times the square root of 2. -2 times the square root of 6. Again, I know a 2 and a 3, I'm not going to get anything out. -2 times the square root of 2 times the square root of 3. -2 times the square root of 6. -2 times -2 is a +4. And the square root of 2 times the square root of 2 is a 2. Be careful, that back number's an 8. Where do you end up? 3 plus 8 is 11. And a -2 of them and another -2 of them is a -4 of them. How many got 11 minus 4 times the square root of 6? Or minus 4 times the square root of 6 plus 11? Okay? And the rest of you find your mistake and figure out where you went wrong. And the problem is, again, you got what? 1, 2, 3, 4 multiplications, 1 addition. So if you go 4 for 5, you're going to get the problem wrong. So you got to be careful. You got to be 5 for 5 if you're going to get it. Questions on that? Questions on it? It's just two binomials, right? We're just multiplying. We know how to multiply. We're simplifying. We've already learned that. Multiplying and simplifying. Okay, division here. What are we going to do with division today? We've already done division, but this is going to be a different situation. All right, dividing by a binomial with a radical. All right, I want everybody to look right here for a moment. Here's what we've done so far. We've done something like this. 2 divided by the square root of 5. And we're told that if we leave a radical in the denominator, the radical police will issue us a radical citation and it will radically lower our grade. And that happened to some of you on the test. So what's the procedure to take care of that radical in the bottom? Somebody raise your hand. What's it called? Andrew? So we got to rationalize the denominator. So what do I multiply the bottom by? Kaylin? Square root of 5. And whatever I do the bottom, I do the same thing the top. And I end up this one 2 times the square root of 5 over 5. Okay, good. Here's the thing, though. We do this when that's a monomial. What happens if the bottom is a binomial? Different situation. We got to treat it differently, and that's this next section. So dividing by a binomial. Okay, with a radical. So, just like before, your focus is the denominator because you have a radical in the denominator. So your focus is the denominator. And you have to multiply by its conjugate. I think we've used the term in here conjugate already, have we? I know I have in Algebra 2, and it's hard to keep track which course I'm in, right? Conjugate. So the point was this. The conjugate, we're going to write it one more time because I want it to stick in your brain. The conjugate is the other binomial that would form a, what? Difference of two squares. Okay, so if we're going to properly rationalize the denominator on these, we got to know what the conjugate is. So number one, if you had 3 minus the square root of 5, what would be the conjugate? If you know it, go ahead and write it. If you don't know it, then you're just going to have to look and write after you see me do it. But if you know what it is, go ahead and write it. Right, and hopefully that's what you wrote. Conjugate. Aren't those two now a difference of two squares? Isn't this quantity and that quantity a difference of two squares? What's the basic bottom line? The sign in the middle is different. One's a negative, one's a positive. It's the basic bottom line. Okay, so what's the conjugate of number 2? What's the conjugate of number 2? Now, what I find every once in a while is a student wants to change the front term from negative to positive. Do we do that? It's all about the middle, right? This is 2 times the square root of 7 minus 3, right? Would be the conjugate. Okay, that's important because we have to multiply the denominator by its conjugate. That's how you rationalize the denominator. So this will be the last thing we'll do today. So now you know why we just practiced multiplying by binomials. So what am I going to multiply the bottom by? Somebody raise their hand and tell me what to multiply the bottom of this by so I can rationalize the denominator. Josh? Not enough. Let's pause. Just everybody stop. If you treat this like it's a monomial instead of a binomial, nobody do this. Everybody look. Stop writing and look. Technically, Josh, I now have this. I have to distribute. Square root of 2 times square root of 2 is 2. Good, that worked. However, positive 1 times the square root of 2 is square root of 2. I still now have a square root of 2 in the denominator. Your method didn't work. And if you forget to multiply by the conjugate and you're correct in your math, you'll find out your method didn't work and you'll say to yourself, oops, am I forgetting something? Is this a different kind? Am I supposed to do these differently? And the answer would be yes, because you still have a radical in the denominator. Okay, so I'm not going to multiply by the square root of 2. I'm going to multiply by, Lauren?
Square root of 2 minus 1.
Square root of 2 minus 1. And here's one other thing. You should put these in parentheses when you do so. Here you go, John. Because they're binomials. These are binomials. So you should put them in parentheses. They are binomials. And hey, whatever you do to the bottom, do the same thing to the top. Again, use a parentheses because these are binomials. All right, we'll finish this one off tomorrow.